It's somewhere. I will find it. Alright, so test tomorrow. If you have your test corrections, I told you guys could bring them in today. Did anybody do test corrections and bring them in? They have to be turned in right now. I think you could actually complete them at home and bring them in. No one did them? Okay, today was your only shot to do that. Alright. I don't think this is 9-5, but let's see. Answer key to 9-5. Alright, raise your hand if you did the 9-5. So this is the 9-5 part 2, the odd assignment. You guys did on Thursday. Remember, I was out, but you had a short video. With some notes, and then you were supposed to do the 9-5 odd. So those are up on the board. I'm going to go take roll while those of you who did it are checking it. Everybody else can have pencil and paper out. Get out your review worksheet B from the week before the break, and also today's assignment is 2 pages because that document is just messed up. So you could actually do your work on the second page if you want. There's only one problem on the second page, unfortunately. I'm scrolling. I know that at least a few of you did this assignment, so I'm scrolling down. So everybody's here except for Xavier, I believe. All right, I'm scrolling to the back page. What was the last one we did? Well, you know, if you're not here, you're still supposed to do the things, right? Into the quarter. You should have done them over the break, right? Okay. You got to make up your work when you're out. I'm not a stickler for an excuse versus unexcused, but you do have to do the work. Akira, did you do this one? Kayshawn, you did it? You checking? Jaden, you're checking yours? You didn't do it? Okay. Peyton, stick your head up, baby. Sure. What number? 7? Sure. Let me know if you have any questions. We can work problems from this assignment. I'm going to go back down to any other problems. Alvin, maybe you can't be in here right now. You got to go. This is not your class. I cannot give you a pass or any of those things either. You're not supposed to. What's that? Okay. All right, and let's go ahead and put up the key for review worksheet B, and then we'll do all our questions at once. To get your review worksheet B, this formatting is a little bit weird. It's not exactly like the formatting on the test. Well, mostly just because the numbers are not consecutive on the assignment. But basically, that you all have the same kind of problems. There's something that's a little bit different, and I'm going to give you an example of those. How about I'm submitting you, buddy? You're not supposed to be here right now. You gotta go. Okay, I think this is the right one. You are going to have to graph on the test. I'll tell you how many graphing problems. There's 2 problems to graph, only 2 on the actual test. I think you had, I do. All right, see you tomorrow. You can't stay into the next period though next time, buddy, okay? You guys ready for me to scroll? Did you do this one, Akira? Okay, so test tomorrow, everybody. Anybody do it? Shanice, did you do it? You checking it? Keisha, did you do it? No? Okay. I think I did move the due date for both of these until tomorrow, for the one from Friday before the break and today. I'm scrolling for the few people who did it. I did get your test corrections, the last one, so some of you did a couple weeks ago there, and the tests from the last week are in. Your grades are actually final. The only thing that could have changed your quarter grade would have been if you'd have done the test corrections. So whatever grade you got is the grade you got at this point. All right, this is the back page of Review Worksheet B. So these answers are in Canvas, like I told you guys they would be. So if you're working, I want to rework tonight, problems that you missed, you could go back and rework them and then check the key to see if you got them right this time. For the last one, I just used one of the equations that I graphed, and it fit the requirements for number 25. It said write an equation of a parabola that has 2 x-intercepts and a minimum vertex. So number 7, if you graph that equation, it does have a minimum because that parabola opens up, and it has 2 y-intercepts because the vertex, the y-intercept is below the x-axis, so it would go up and have 2 intercepts. You could also pick any of these up here, anyone that you know would have 2 solutions, and you could use the discriminant to find that. Any questions on 9.5 odd or Review Worksheet B? Okay. So I know we are going to go ahead and work some problems together. If you weren't here Friday before the break or you didn't do it, we're going to start working on today's assignment, which is backwards. Today's assignment is Review Worksheet A. Real quick, I want to talk to you about a little bit of a change in procedure. If you try to turn in your worksheets online, you're going to see that there's no submission spot for your worksheets right now. It says you're going to turn it in on paper. I'm actually going to be out all next week, and you're going to turn your worksheets into this little blue basket, and that's something I'm going to print up front. You turn your worksheets in on paper. I have TAs that help me grade, and then when I get back, I won't be so far behind in my grading. You will still be turning your notes in online. Everybody clear on that? But as far as the worksheets, they'll be turned in this blue basket, and it's going to be right here. And we're going to do that tomorrow too. So tomorrow when you come in, if you don't have any questions on your worksheet, you're going to put them, make sure your name's on them, put them both in here. Okay? So your notes are still going to get turned in online, and it's going to give you a spot to turn it in online. If you try to turn your worksheets in online, there's not a spot. It's going to say on paper, and that will remind you that they need to go in here. Fair enough? So my TA can help me grade a little bit. I'll have them put it on the spreadsheet, and then when I get back, I'll be able to put it in the computer a little bit more quickly, and I won't be so far behind. Fair enough? I like to give you guys fair warning, so I'm going to talk a little bit more about that before we do some problems, but so I'll be out the whole week, but you'll be watching videos, taking notes, doing practice problems. If you have questions, you should always go to the home page in Canvas. The answer keys are going to be there. They're almost always there. They'll be there next week. But very often, too, there's videos that will have some of the problems from each assignment worked out. And so you can look there for those. Any questions? So you're still going to have to be working because I'll be back the following week, and I'll be back on that Monday, and you guys will be testing on Wednesday. So we'll have a couple days that I can help you if you have questions on things. So it's going to require you to be on task and being responsible for your own lesson. Anybody have a question for me? Okay, test tomorrow. Anybody have a question about that? All right, well, let's go ahead and get started and let me give you some reminders about some things that you need to know for this test. So you are going to be able to use some formulas, and I actually will probably just put the formula up, but go ahead and get this formula sheet out, either a yellow one or a green one. Everybody was supposed to get a yellow one or a green one. If you weren't here, you did, because you had your name on one. It was marked in here somewhere. You can have that one, Rick, that will be your second one. So I thought what we would do is go ahead and work some problems from each section. If you're someone who actually is going to work on your own, I'm happy for you to work on your own. But if you look through and you have some questions on problems, you want me to work particular problems with you, we can do that. A lot of you, let's be real, you don't do your homework, and you won't be able to do it unless you're working with me today. Right? So I will tell you, there are a lot of these problems that if you were just working with me today, you might could get them right tomorrow if you're paying attention, right? You are going to be required to solve certain quadratic equations using a particular strategy. I will tell you, though, if you solve it using whatever strategy and get it correct, I'll give you at least 1 point, right? This first two problems, it says find the equation of the axis of symmetry and the coordinates of the vertex of the graph of each function. So this test tomorrow is on everything we've learned in Chapter 9, and this will be our third or fourth test for Chapter 9. I can't even remember now. But I know we did a 9-2, I think we did a mid, so I think this will be our third Chapter 9 test. So you have to be able to find the axis of symmetry. You have to be able to use that axis of symmetry to find the vertex. So that's what we're going to do first. Everybody should have 2 pages, not just a worksheet with 1 problem. You have 2 pages to vary, so it looks like I only see 1 for yours. Everybody should have 2 pages. All right, so the very first thing almost always we need to do, not always, but almost always, and in particular if we're finding the axis of symmetry, we want to put that quadratic equation in standard form. So everybody, let's go ahead and write the standard form for a quadratic equation. Up in the top left corner, add your worksheet. Ax squared plus bx plus c equals 0. We've been working with standard forms of quadratic equations for months now. The number that is with being multiplied by the squared variable, that's your a. The number being multiplied by the variable with no exponent that we can see is the b. And the c is always the term with no variable. Right? In order for those to be a, b, and c, they have to all be on one side of the equal sign, and it's got to be equal to 0, or equal to y, or equal to f of x. Those will all be the same thing. So this first set of problems is find the axis of symmetry and the coordinates of the vertex of each function. So this is the formula for the axis of symmetry. The axis of symmetry is going to be x equals some number, and the vertex is going to be an ordered pair. You have to find the axis of symmetry. You go to find the vertex. And these for now, when the equations are in this form. So that's what we're going to do first. So for number 1, what is my a, what is my b, what is my c? So this is a y. We can also just think of that as 0. Right, so what is my a, b, and c for number 1? What is a, b, and we actually only need a and b. So we're looking for our axis of symmetry. So what is the a to this quadratic equation done? Perfect. And what is our b? What's that? It's 0. Very good. It's 0 because there's not a term that's just a variable, right? So now our axis of symmetry, I'm going to do mine over here because I don't have any extra paper, but my axis of symmetry is going to be x equals the opposite of 0, all divided by, so remember this is the formula we're using, 2 times a. I will tell you tomorrow, I am going to put the quadratic formula on the board, but I'm not putting anything else on the board. I'm not going to give you the formula for the axis of symmetry, I'm not going to give you the formula for the discriminant, and the reason is you do not get to use those on the end of course exam. Right? On the end of course exam, you'll have some version, won't be on green paper, but it's going to look exactly like this reference sheet that you have. So I'll have the quadratic equation on the board tomorrow, but all the other formulas you have to remember. All right, so if we plug this, not 2a in the sermon, a is -5, so we're going to plug that in. Over 2 times -5, and that's 0. So now we know that our axis of symmetry is x equals 0. Does anybody remember what goes in the first spot of our vertex? Right, it's always the axis of symmetry, so that one always goes there. And how do we find the y? Plug the 0 back into the original equation. So y equals -5 times 0 squared plus 1, and so y equals 1, and that goes squared. So that is a solution, or the answer to that first problem. Axis of symmetry is x equals 0. Remember, axis of symmetry is an equation. It's got to be x equals. Yeah, if you remember that, Akira, you don't have to. Yeah, if you remember that, you don't have to show me that work at this point. Early on, I wanted you to show me that work. But if you remember that anytime b is 0, that the axis of symmetry is x equals 0, I'm fine with that. Okay? I'm just doing it. I like to teach it. Everybody do the same thing every time, so no matter what little wonky difference there is, everything comes out the same. Lee? No, we're not going to the music today. Thank you for asking, though. I'm going to skip the graphing for now. We have graphed a lot, and this is not anything new. We got the 9.2 test, which most of you killed. Well, a lot of you did really well on. I think there were 10 or 11 100s on my two sections, 40 people, so a ton of people did well on that. You guys let me know later if you want me to do one of those, and I will. But for now, I'm going to go on. There's only one of these on the test, but I will tell you there is one of these on the test. It's a 5-point question, 2.5 points for A, 2.5 points for B. I don't know that the questions are exactly the same, but it's about one of those, what do we call them, projectile problems, right? So, I will tell you there is a question on that. Let's do one of these problems. It says solve each equation by finding the square root. If the equation has no real solution, write no solution. So finding the square root means, well, the only time we really want to solve using the square roots is if we can isolate the square variable on one side and a constant on the right, or if it's a perfect square trinomial, or if we've been asked to solve by completing the square. Here, they just asked us to solve this equation by finding the square root. So we can do 10 or 11. Anybody have a preference which one we do? 11? Okay. So the first thing we're going to do is we're going to get the constant on the right side. And how would we do that, David? How would we get the negative 192 on the right side? Well, it's already subtracted, so what would I do? What's the opposite of subtracting? Yeah. So we're going to make it disappear from the left side and move it to the right side, which is do the opposite. So now we have 3x squared equals 192. We can't just take the square root yet because there's a number with the variable. So we're going to divide both sides by 3, get that x squared by itself. And so now I have x squared equals, I don't know what it is, I can tell you, by 64. And now this is where we take the square root. What's the square root of x squared? And what's the square root of 64? 8. And this is someplace for a lot of kids, this point from the last test that I graded over the break. It's not just positive 8, it's also negative 8, right? Negative 8 squared is positive 64. Positive 8 squared is positive 64. So our solution would be negative 8 and 8. Okay? So completing the square, let's actually do these out of order a little bit. You guys caught up with me? Okay. Let's look at one of these, 13, 14, or 15. So if we're solving a quadratic equation by completing the square, that's it. Where's your pencil, baby? Well, you need to get your pencil back, baby. Go ahead. I'll get him a pencil. Thank you for loaning him one. Peyton, but you and I have talked about this. You definitely need to be using a pencil. Coming up, Corey. Okay. So I want you to go out on the left-hand side of these 13, 14, 15, these problems, and write this formula. B divided by 2 all squared. So parentheses, B over 2, close it, and square it. You're going to do it right here by number 13. Find the value of n such that each expression is a perfect square trinomial. When we solve by completing the square, we need to be able to create a perfect square trinomial, and this is the strategy we use. So we need to find a number that's the constant, and if we plug, add to these first two terms, it's a perfect square trinomial. So remember, our perfect square trinomial is the product of a binomial squared. So this is not going to be here, but this is the example of a binomial squared that would give us a perfect square trinomial. Oh, right, perfect square trinomial factors into that. So this formula, b over 2 squared, will give us what the value of that constant needs to be to make that a perfect square trinomial. And we need that when we're completing the square. So A is 1, B is 18, C is what we need here. So our N is 18 divided by 2 all squared. 18 divided by 2, you can do this in the calculator. If you do 18 divided by 2 equals, just press the x squared button. That'd be 9 squared, so that value is 81. Right, so if n is 81, then that a squared plus 18a plus 81 is a perfect square trinomial, and then we can factor it into a binomial squared if we're completing the square. Danielle. Danielle, do you need to the clinic or guidance or somewhere? Then pick your head up. Pick your pencil up. We're doing your homework right now. Yes. You can wait. We're going to come back to that one. We are going to write these things as well, but we're going to come back. Because right now we're going to go back to the completing the square section. So the first thing we're going to do, it's at the very top. Okay. So we are going to complete the square. So the top of the back page, n squared minus 4n equals 1. Actually, we're going to do number 2. Because number 1 part of it's done for you. Right? Number 2, you have to do all the steps. So we're going to do number 2. Are you saying everything's out? I'm still here, Fatima. Okay. Can you see all right for that? Okay. All right, so for number 2, we need to, the directions ask us to solve by completing the square. So we need to create a perfect square trinomial on the left side and move the current constant to the right side first. So the constant -5, how am I going to move it to the right, Kayshawn? I'm going to add 5 to both sides. Danielle, we're on the back page at the top. So now we have b squared plus 6b. I need to know, this is my n, what am I going to add here? And that's going to equal 5 plus that same thing. So this is from 9, 5. So now we're going to use this. So this is our n, or our constant, that we're adding here. Our b is 6. So we're going to use this formula. 6 over 2 squared, right? So our b, which is 6 in this problem, divided by 2, which is 3. 6 divided by 2 is 3 squared. So that's 9. So 9 goes here, but if we're using this to solve the equation, we're going to keep our equation balanced and do the same thing to both sides. Any questions? What we've done so far, Ulrich? All right. Now we have a perfect square trinomial on the left, and so we're gonna go ahead and rewrite that. I'm out of room, so I'm gonna come down here and work. So this factors the square root of b squared is z. The square root of 9 is 3, and that's a plus, so it's a plus. Everybody remember that? Any questions on how I got b plus 3 there? Perfect square trinomial is one of those special products, and it has a shortcut to factor it. square root of the first term. Let's use the operation from the middle term, that was plus, and then the square root of the last term. And now, when you're completing the square, you have to make a perfect square triangle, but then you're also using the square root method. Right? So now we're going to use the square root of both sides. Square root of the left side. What's the square root of b plus 3 all squared? Perfect. B plus 3. And take the square root of the left side to the square root of 14. We're going to round to the hundredth place. I'm going to put it like this to do the other, so you guys don't know how to simplify radicals yet, so we're going to simplify or take an approximate answer. 14 square root value gives us 3.741 on the calculator, so we're going to round it to 3.74, but remember, it's positive and negative 3.74. So the negative 3.4 squared is approximately 14, and a positive 3.74 squared is approximately that. So we're going to rewrite it as two equations now. B plus 3 equals positive 3.74, and B plus 3 equals negative 3.74. Anybody have a question about how we got there? And then we solve. Perfect. Subtract 3 from both sides, and that is 0.74. My board doesn't want to write. And then subtract 3 from both sides here, and B is negative 6.74. And we're going to write it in notation. My board is not quite ready. Negative 6.74 and 0.74. Okay. The quadratic formula, I'm going to wait and do those in a minute. I do want you to look at 11 and 12 here. Just find the number of solutions. That's when we use the discriminant. Remember, that's the part under the radical in the quadratic formula. So if you forget that, you will have this formula in front of you. So I will have this formula on the board tomorrow when you come in. Right, and this part is a discriminant. That part tells you how many solutions there are to the equation. So remember, you don't take the square root. I'm going to flip over or go down to number 28. This is the answer to number 28. I'm just going to go ahead and tell you right now. It says, how can you use, explain how the value of the discriminant b squared minus 4ac can be used to predict the number of solutions an equation has. You can say, if it's negative, so if the discriminant is negative, there's no solution. If the discriminant is positive, there are two solutions. This is number 28. So go ahead and fill in number 28 right now. And if the discriminant, if the value is equal to 0, then there's one solution. You may have that exact question on the test tomorrow. It is possible. So if it asks you to find the number of solutions, you can use a discriminant. You can also use, does it open up or down on the y-intercept, but the discriminant is what we let you use. And go down to number 18. Number 18, it says how many x-intercepts. That's the same thing there, right? X-intercept is another way of asking how many solutions there are, how many zeros, or how many roots. Yes, please. Have you caught up with me yet? Have you caught up with me in the weekend? I don't think you're caught up with me yet. You got 18 written in and 28 written in. You didn't write the formula there for that. Right, so you're supposed to have all those formulas written. Literally doing your homework with you, the least you can do is write down what I asked you, right? You'll have it to work with on it. You do it tonight on your own. Okay, so if it says how many solutions are there, or how many x-intercepts are you, you're using the discriminant. I'm not giving you that formula, but this formula will be on the board, and I will not have the discriminant underlined, disregarded. One of the things you have to remember, don't take the square root. The value of the discriminant is not the square root of that, it's just what's under the radical. Okay? Okay, so we can go back up here. Let's just do one of these. You want to do 11 or 12? Sorry? 11. Alright, so let's do 11. Just find the number of solutions of each equation. To do that, we need to know, if we're going to use this formula, we've got to know what our A is, our B is, and our C is. In order to find our A, B, and C, then we've got to be in standard form, so this has got to be equal to 0. How do we get that equal to 0, Annabelle? I want 0 here, right? So what can I add 2 here again? So if I add 2 to both sides, now I have 2h squared minus 3h plus 2 equals 0. Now I can use, okay, that's my A, that's my B, and then my constant is positive 2. Make sense? Make sense? Does that make sense? Okay. So now we just use this formula. So B, negative 3 squared, minus 4 times A is 2, times B is negative 3, times C is 2. Oh, wait up. Oh, I got too many things there, don't I? I did the plus one. Maybe 4 times A is 2 times C is 2. So, that's going to be 9 minus 16, which is negative 8. Let's do them calculator check me. Do you negative 8? Negative 7. 9 minus, oh yeah, negative 7, not the negative 7. So this is the value of the discriminant. If it asks you the value of the discriminant, you tell them negative 7. If they ask you how many solutions, you go over here. Oh, the discriminant is negative, there's no solution. Does that make sense, Diane? Okay. So for number number 11, the answer is no solution. That's not a great spot. So, no solution for number 11. Mrs. Zimmerman. I do. Sure. Bye. To Corey, would you go down to the attendance office? They said you'll be right back. Grab the pass off the wall there. All right. So I think, on the wall right there. Let me count it. I think number 19. This is a question that I thought would be really easy. On the last test, a lot of you, dare I say most of you missed. Some of you, I could tell, you probably knew the answer, but you did not use the vocabulary, so I couldn't give you credit. How do you know by looking at the equation of a quadratic function whether the graph will open up or down? So if I have quadratic equation going to open up or down? Up? How do you know? Yes, and that's what I got because it's positive. There's no such thing as a positive equation, right? What's positive? Not the axis of symmetry. The A. Isn't this the A? This is the B, and this is the C, right? If the A is positive, it opens up, right? What if that A were negative? It would open down. So if A is negative, it opens down. So you can't think if it's positive. You can't say if the first number is positive. You got to say if A is positive, it opens up. If A is negative, it opens down. I want to show you there are 3 problems, and these should be really easy problems. We didn't have an example exactly like it in your homework, so I'm going to show you how to do these problems right now. And I'm going to use answer key, I think, from today. So let's look at them. All right, let's do this. I didn't copy and paste it before, and I think it would be less confusing, more helpful if we copy and paste some things, so give me a second. Okay. So one of the questions on your test, well, actually 3 questions, but the set of instructions are going to say, given these 3 equations, you're going to match the equation with the graph, okay? So I'm going to just give you 2 and show you what that's going to look like. And one more. We'll have an example that looks very similar. I really like that one. Yeah. Actually, that's good enough. Those 2 will be good. Sorry. Y equals x squared plus 10x plus 7. Y equals all right, so if I know, and if you were paying attention, you already know which one goes with which. But if they give me, Naya, look it up here, baby. Literally, I'm telling you, there's 3 problems on the test, and I'm telling you how to do them right now. They'll be very easy. What is the y-intercept of this first equation? Positive 7, right? So, which equation, which parabola has a y-intercept of positive 7? Well, this one right here, right? So this equation has to go with that graph. What's the y-intercept of this parabola, Brandon? Negative 3. So it's right right there. So this equation has to go with that parabola. The other thing that you'd be looking for is they might have a parabola, there might be a third one, and if it opens down, let's say, then we know that the a's got to be negative, right? So this might be a equals negative 2x squared plus 5x plus 1. So the y-intercept is 1, and it opens down. Does that make sense? This is totally not the equation for that parabola, but does that make sense, Ulrich? So you're really just looking at the a and the y-intercept. Okay, there won't be any tricky ones. On these three problems, there'll be one equation for each graph. So if you miss one, that means you're going to miss two, right? So all you have to do is look at the y-intercept and look at the a, is it opening up or down? Any questions on that? Does that make sense to Kara? Okay, Sean, Jaden, Brandon, make sense? Diane, does that make sense? Okay, other than that, I think that I'll have a video on your homepage in Canvas. Some of the problems from these worksheets are worked out, I think, on both the A and the B. So if you need help tonight, you can look at those. Do not do any problems using the quadratic formula. The quadratic formula is a plug and chug. Put it in standard form, find your A, B, and C, and plug it in. Those should be the easiest ones.